Shri Gurubhyo Namaha. Welcome to our online learning initiative Ekalaiva.
Let us discuss circular motion of a car on a level road. When a car negotiates a curved level road, the force of friction between the road and the tires, which provides a necessary centripetal force required to keep the car in motion around the curve. Now let us consider a car of weight mg going around a circular road of radius r with constant speed v. So the weight of the car is mg. The car is going around a circular level of road of radius r with constant speed v. While taking the turn, the tires of the car tend to leave the road and go away from the center of the curve. The force of friction F1 and F2 act inward at the inner and outer tires respectively. So these are the two forces of friction, that is F1 and F2 act inward and at the inner and outer tires respectively. If R1 and R2 are the reactions of the ground at the inner and outer tires, then what is F1? We know that F1 is equal to mu R1 and F2 is equal to mu R2, where mu is the coefficient of friction between the tires on the road. And here one thing we have to notice, children, this weight of the car, that is mg, which is balanced by the normal reaction R1 plus R2. So can we write R1 plus R2 is equal to mg? Yes. Now what is the total force of friction? Total force of friction is equal to F1 plus F2. That is mu R1 plus mu R2, which is equal to mu R1 plus R2, or else we can write mu into mg, because already we know that this R1 plus R2 which balances the whole weight of the car. Then for the car to stay on the road, the maximum force of friction must be equal to or greater than the centripetal force, that is mu mg should be greater than or equal to mv square by r, or else we can also write this m and m get cancelled, v square by r is less than or equal to mu into g or else we can write that b square by r is less than or equal to, bring this g also to the denominator. It will be easy for us to calculate what is b. So b square by, bring this g to the denominator. So b square less than or equal to mu r g. So this is a very, very important expression, children. Now let us see what is the maximum speed with which the car can take a turn safely. The maximum velocity is equal to root of mu r g. If the speed exceeds this maximum velocity, then the car will skid and go off the road in a circle of radius greater than r. This is because the maximum available friction is insufficient to provide the necessary centripetal force. And we can notice one thing here, the maximum safe speed, which depends on the radius of the curved path, and also it depends the coefficient of friction between the road and the tires. So what is the maximum velocity? Which is equal to root of mu r g. So the maximum velocity, which depends on coefficient of friction as well as it depends on the radius of the curved path. To receive our online lessons, please press the subscribe button and you will receive the latest updates. Thank you, students.